Okay, we're gonna go ahead and get started. I'll be talking about intro to databases before Johan dives into the workshop with you guys. So let's get started. You remember in our previous workshop with Noah and so we have this local variable called data that stores all our stories. But you remember whenever you modified your code and you would it would restart the server and you would kind of lose everything, and you'd have to keep replaying, like keep posting new stories and comments just to see it. But there's like a lot of other stories. I mean, a lot of other problems we have, because like, what if you close terminal, or like your server crashes because it's hosted on your laptop right now, or like your laptop runs out of battery, like all your data is gone. There's a lot of reasons why we don't want to store our data just locally on our computer. And the answer to that was going to be databases. I'm going to go over a couple approaches in this intro lecture to see why we should use a database and what way we can use it to best store all of our stories and stuff in Catbook. So you all should have done the MongoDB setup. It only takes like 5 minutes. You haven't, just do that now. But yeah, so, oh, I didn't go. Another thing that database helps us handle is, like, if you have a lot of data. So first of all, if you're storing all your data locally still in this variable, you have thousands of users and they make a ton of stories and comments, it's popping off. Your computer will run out of memory and you will be very sad. So this is not the best. Like, we need to also store them permanently. As I said, every time you modify your server code, and it would refresh and you would lose everything. So one approach that still isn't the best, but I'll go over just to demonstrate what we're looking for in a database, is using something called data.txt. What if we stored all our stories and comments in a handy dandy file called data.txt, store it on our hard disk, like, so that would store everything permanently, persistently. It would work throughout your server refreshes. But do not actually use this approach because you will not pass web lab. This is more for demonstration purposes. I'll show you guys some code snippets. So let's say we're using this data.txt approach, which is a little better than storing things in a local variable, but we're not quite at the level we want yet. Let's say we're doing this. We read the data from the file in this little function here. We parse it, and then when we save data to it, we write the data to the file. You don't have to really understand what these functions are doing inside. Just think of, I can black box them in your head for now. But for example, let's say we post a new story. We push it to our variable data.stories.push. And then we write all of that data to our file data.txt. And then we load any new stories from our data.txt file by using the read data from file function. So let me show you guys why this can be bad and how it works. So right now I'm running a version of Catbook. You don't need to follow along on your code for this. I'm just going to show you guys. But in the code here, we have, my bad. Okay, so you can see the functions I was talking about: read data from file, write data from file. And then we read it here, blah, 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 blah. I'm going to post something on Catbook. There's already something here. Hello. This is a comment. Okay. So.
Hey, Shane, can you zoom in on your code?
Oh, yeah. Okay. Cool. So right now, if I refresh the page, if I restart my server, which I'll show you right now, I'm going to Control-C to set my server. I'm going to restart it. And you'll see if I refresh the page, all my stories are still there because I use this cursed data.txt approach, which we can see right here. This is data.txt. It's not very pretty, but it did store everything I want. It satisfied some of the requirements I was looking for to store my data persistently. But you can imagine what happens if this file gets really, really huge. And there's a lot of other cursed things about it that I won't go into, but this demonstrates my point. So let's go back to this. So data.txt, basically, we have saved every story or comment whenever someone posts. Because of that read and the save function, it saves every single story again, even ones that are already in the data.txt file. Very bad. This is not optimal. Also, for memory usage, it still keeps all your stories in RAM. It does persist it, but still, if you get a lot of stories, you're kind of screwed. And also query speed. This is very important. So to find a story with any particular ID, we're doing a linear search of the stories too. We have to do that to get it. We don't really sort this by any means. We kind of just throw in data.txt and yeah. We ideally want to find and query for documents fast because we want to return them to the user fast. And another one, there's a single point of failure here. If your laptop hard drive breaks, runs out of battery, you throw your laptop out the window, yada, yada. And another thing that I want to bring up is concurrency issue. So if two users post at the exact same time, and we're all trying to write to data.txt stored locally on your machine, it will break somehow. User A might overwrite user B's, user B might overwrite user A, but bad things will happen. And it is very unsafe to use this fs.write multiple times on the same file without waiting for a callback. And you can imagine if we're waiting for the callback and line up every user, it's going to take a long time for anyone to save a new story or post. So we don't want to do that. These issues have all been solved for us by using databases. So you might have heard of some of these. So like MySQL, PostgreSQL, SQLite, MongoDB, which is what we'll be using in this class. A database is essentially an organized collection of data. And database management system is software that facilitates interactions with a database. Usually when people are talking about different databases, they're referring to actually the management systems, and they like to use the terms interchangeably, but I did want to point out the differences here. So to provide a visual example, let's say that our database here is this nice warehouse, lots of boxes, lots of stuff, and we have a nice database management system, this little penguin man here, and the user. So if he's reading from it, he'll be like, give me stories. And the penguin will be like, okay. And we'll go to the database. And then he's going to wrap up all the things you want nicely, like exactly what you want, specific stories or whatever the user requested. And he's going to fly all the way back to the user and be like, here's the data. Hey, that's how you read from a database. And then so for writing to the database, they'll be like, put this new story in the database, or put this new comment in the database, or edit this story in the database, any of those things. The user will wrap it up in some sort of call, and then we'll go to the database, we'll put it in, and then we're happy. We can look at pseudocode for this. This will not work if you try to run it. This is just pseudocode. But basically, you can think of this database management system as the strings inside is basically the query, what you want. So this can be give me all stories, or only give me the story with a specific ID, or put this single story in the database, or delete any story posted by Aaron, or change the author of this specific story to me. Writes, reads, deletes, and updates are all different functions that a database management system can handle. So there are a lot of different databases out there. You might have heard of relational databases, which stores data kind of in tables. So it'll look kind of like this. SQL is a good example of this. And what we'll be using, though, is a document database. We're not going to be using SQL. This will store documents, which are JSON objects, which you've seen in previous lectures when we talked about the JSON objects. This is kind of like what the story looks like. And we're going to use MongoDB to do this. And you're already familiar with JSON because you went to all the workshops or you watched the recording. So MongoDB, which you should have done the setup for, this is just kind of their blurb, but TLDR, it's a document database, stores data in JSON-like objects. So the hierarchy of MongoDBs looks kind of like this. So we have our database, let's name it Catbook, and then we have different collections. These are for different types of documents. So a story is obviously a very different kind of document than a comment. So they're stored in separate places. So we have documents inside collections. And you can see here, these documents for comments, like our comment object has a parent ID, which differentiates a little from story, and well, yada, yada, yada. So we're going to replace data.txt, burn it to the ground. We're never going to see this again. Do not use this approach. We will not pass web lab. Someone actually did try to use this approach last year. So we're trying to emphasize you should use MongoDB or some other database. You just have to approve that with it. But yeah, now we're happy. But there's still some issues we need to solve. So we've optimized our write speed because we're using a database management system. They do all that for us. Memory usage is optimized. Query speed is optimized. And concurrency issues are solved. But if you're like hosting an instance of MongoDB on your laptop, your hard drive could still break. So this is why we had you made an Atlas account, because MongoDB will be run somewhere else on the quote cloud. This will make your life a lot easier because you're not going to be running or hosting the database on your laptop. It's managed for you. And most importantly, you can share the data with your teammates. This is kind of how we had you talk to our API in the past few days. You'll notice you saw everyone else's posts as well. And yeah, so this is a lot more reliable than your laptop SSD because behind the scenes, they'll replicate your data, shard it for you, do all that good stuff that I won't get into. So our Catbook configuration without Atlas would look something like this. Your server would talk to a MongoDB that's hosted on your hard disk. However, if it's over the network, that means making it a lot safer, it's replicated, share your data with teammates, all those other points I need. It'll look something like that over the cloud. So once you're sharing your data with teammates, that means your teammate's server and your server can all talk to the same database, as long as you guys have the same like SRV string that you guys copied. And you'll never lose data. So basically a replica set is when they copy your data to multiple machines. So that ensures if one set is broken or it's got deleted or something happens, we'll just replace it with one of the other instances. I'm not actually going to demo this for the sake of time. You can see this in Johan's workshop. But yeah, so right now we've written a lot of API requests that will do something with our data. So in this case, we have a GET request that gets us all the stories. The user sends it over, the server processes it, and basically what your server should do is ask MongoDB, hey, get me all the stories. And then the DB will send it back. And then your server should respond to the client with the stories. And then the client will, the front end code basically make it look all nice and present it to the client. That's kind of the flow here. But yeah, so the main takeaways from this is that you need to save stories and comments permanently. This is one of our requirements for like milestone 2, the MVP, and the final project. You need to use some kind of database. You need a smart solution, and database happens to handle all of this. And last of all, if you're having troubles using MongoDB or sending out that, you should contact your staff. But usually once you have the SRV string and you replace the little carets in there with your actual username, password, not from the MongoDB instance, but from the user you made on the account, you should be good to go. But yeah, I'll hand it off to you.